Hi, welcome to an ESP8266 tutorial by Robojax. My name is Ahmad Shamshiri, presenting this review from Canada. In this tutorial, we are going to learn how we can use ESP8266 to measure the temperature using this DHT11 or DHT22 or DHT21 temperature sensors and access it over the Wi-Fi from the same network of your home, either using your mobile phone or your computer. Here are the topics covered in this video. First, we will have introduction to web server. Then we will explain the wiring. After that, we will show you how to prepare your Arduino IDE for ESP8266 boards. Then I'm going to explain the code. After that, I'm going to do the demonstration with DHT11 temperature and humidity sensor. Then demonstration with DHT22 quickly. And then I'm going to demonstrate it on the mobile phone. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. With the availability of Internet of Things or ESP8266 Wi-Fi microcontroller module, you can measure temperature over the Wi-Fi. And we are using in this tutorial DHT11. And you can use DHT22 as well, either as a PCB module or without a PCB, a bare module, which I'm going to show you how to wire this with another simple resistor. Microcontroller will read the temperature from this sensor and make it available over the Wi-Fi. So you can use either your browser or your mobile phone to monitor or see the temperature wherever you put this microcontroller. Now let's see how we can use ESP8266 Wi-Fi microcontroller module with DHT11 humidity and temperature sensor or DHT22 humidity and temperature sensor. I have separate video explaining DHT22 and DHT11. For both of these, I have separate video. The links will be below the video in the description. Now let's see how we can use ESP8266 Wi-Fi microcontroller module with DHT11 humidity and temperature sensor or DHT22 humidity and temperature sensor. I have separate video explaining DHT22 and DHT11. For both of these, I have separate video. The links will be below the video in the description. In order to use this DHT11 or 22 with ESP8266 over the Wi-Fi, we will configure ESP8266 as a web server. Now let's see how it works. For example, you have your mobile device, laptop, which is connected via Wi-Fi to a web server. So let's say when you type an IP address 192.168.1.100, this is within the same network of either your home or your company. So the two devices, your desktop and the web server, a machine, a computer that acts as a web server, will respond. And this communication can be via your internet service provider. For example, when you type robojax.com, the information goes to your internet service provider to the internet, and from there the server will respond back and you get the information based on the configuration of the web server. And your communication could be within your network over the Wi-Fi, and in this case you can type an IP address of your local IP address. It goes to the Wi-Fi router, and from Wi-Fi router, where it is connected to the web server, it will respond. Now we can replace that web server, which is a computer, with a ESP8266 as a tiny web server. So this can be configured as a web server and will respond to our request. So ESP8266 will communicate with a Wi-Fi router, and from Wi-Fi router the communication is established with your laptop, and this way you can communicate with the ESP8266 and the information will be displayed on your computer screen or your mobile device. Now we can connect DHT11 to ESP8266, so this can read the temperature or humidity values and then it will communicate to the router, and from router the information comes on your computer screen. We can replace the DHT11 with DHT22. It will act exactly the same way. Or maybe you can replace your laptop with your mobile device because it has a web browser. In both cases we are using web browser, and you will see the response of ESP8266 on your mobile device screen as well. Your ESP8266 can read temperature from DHT11 or DHT22. Then make sure to use it with a serial monitor. Do not try it over the Wi-Fi. Make sure you're able to read. And if you had problem with that, then go back to Arduino Uno or Arduino compatible boards to make sure that you can read the value on the serial monitor. I will provide you the link that shows that DHT11 or DHT22 is used with Arduino Uno or Arduino compatible boards. Let me explain the wiring. I'm going to explain first with the PCB, then I'm going to this. We have 3 wires. It has been labeled as here as a plus, and this side minus, and the middle is out, which will give you the signal. This will be connected to 5 volts. The minus will be connected to the ground, and this is a signal out, which will be connected to GPIO2, which is labeled as pin 4. On the module that has CP2102 USB chip, it is labeled at 3.3 volts where you will connect it. And on the module with a CH340 USB chip, it is labeled as 3V. So that is also 3.3 volts on ground. But you can connect it to any other 3 volts around in this module. And here is how you connect the wires. From the positive, you will connect it to 3.3 volts at this pin, which is labeled as 3. And if you have this module, it will be called 3.3 volts. Then the last pin is negative, has been connected to G here. And if you have this type of module, it will be G in D or ground. And then the middle pin is the output. The output is connected to D4 here or D4 in here. Okay, the first thing that we do is when I insert this here, for this we need an extra resistor. On this module they already have the resistor here, so they make it easy. But here doesn't matter. For this module we have 4 pins. I've inserted here a resistor between pin 1 and pin 2. And then here the other side is exactly as the other module, except here 1, 2, and then the third one is empty, and the white is at the 4th pin. You always leave the 3rd pin unused. The first thing that you need to prepare is your Arduino for ESP8266. I have a separate video explaining that, but here I can tell you quickly. Click on File, Preferences, and then Additional Board Managers URL. Click here, and then paste the link that I provided. I will provide you this one, so you copy and paste it here. Once you paste it, you click OK, and then click OK. This link will make Arduino to know where to look for the board. Click on Tools, Board Manager, and then Board Manager. Wait for this to complete, and then you will be able to type. Once you are able to type ESP8266. Then you will see this ESP8266 by ESP8266 community. In this case, it is installed, and I have a remove button. In your case, if you have not installed it, you will see here install button. Click on it and wait until the bar graph finishes, and then close. Then we need to select the board by clicking Tools, Boards, and then scroll down until you see ESP8266, generic ESP8266 module. Select that. Then we have to tell the port that the device is connected. Now I'm connecting my board. If you don't know which port it is, right click on Start menu, go to Device Manager, and then under the port, collapse this arrow, and this is a port USB serial CH340, or maybe you see another one, but this is a COM port 11. Then we have to go in Arduino, click on Tools and come to the port, and then make sure to select the port that is connected to your USB. In my case it will be 11. Then your Arduino is ready to accept the code for upload. You also need to download the DHT driver and make sure it works. I will provide you the zip. Once you download the zip file, click on Sketch and then include library, add .zip library, and then point it to where you have saved it, browse. In my case, let's say this was the .zip library for DHT, and click open. Once you click open, and here this line, it says constant integer refresh. This is the refresh rate of how often the temperature is read or displayed on the screen. This 3 means 3 seconds. If you want to speed it up, make it 1 second every 1 second, or make it 10 seconds. So this will read it. And this line, it says start of DHT11, and that is the end. This include DHT.h is a header file which is part of the library. Define DHT pin. I'm using GPIO pin 2, which is labeled as D4. You can change it accordingly if you wish. And then this library can work with DHT22, 21, DHT22, and DHT11. Whichever you're using, make sure to uncomment it. In this case, DHT11 is uncommented, and if I was using DHT22, I will uncomment this and then comment the above. So you can select the one that you want to use, and then we are creating an instance of this DHT, and we call it again DHT with lowercase, and we pass this DHT pin, and we pass the type. 2 values, 2 parameters will pass to this class. This constructor will initialize it, and then float T value or temperature value is the value that we send over the web, which will be used later. Keep that in mind. These 4 lines: ESP8266 Wi-Fi, Wi-Fi client, web server, and this is multicast DNS. These are all part of preparation of Arduino for ESP8266. This you don't have to worry about it. Here enter your SSID, and this is your password for your Wi-Fi. I have separate router for this purpose, so I'm not worried if you know this password. It's not a security risk. I will turn it off when the recording finished. And then we pass those values here, and now they are assigned to a lowercase SSID and password. And then we initialize using the server. We initialize the server with a port 80. HTTP has different ports, so for HTTP we use port 80. And this is a function that I have written, send temp. The job of this one is to send the temperature and print it like a page. This is a code for a page. You see all this text. These are the HTML for that, which means behind the scene is these text. So we have document type or doc type at the top, and then we have HTML and HTML close. You see the slash at the beginning, that's a opening tag, that's a closing, body, and then body, and then we have some text. This is paragraph, Robojax test, and then the red. I'll provide you the link if you want to play with it. So I'm printing those values, but because I'm assigning the page as a string, I have to put quotation at the beginning and end. This \n is a 2 new line, and then page, we are concatenating this meta tag, HTTP equivalent refresh, and then content is the time. So here we put 3 or 4 or 5, which is here. This refresh is coming from the top, which we define, and we convert it to a string, and this will be concatenated using this plus to page, the page that we define above. Slowly we are stitching this text to it, and then the number after that, this closing, the HTML body, and then this text temperature, and then the style for red for temperature, and then actually T value. This is a temperature value with 2 decimal place. We're converting it to string and stitching it to page string, and then the P is closed, the paragraph, the body is closed, the HTML is closed, and then this page is holding all the elements of a page that is displayed on browser. And then using server.send, we have three parameters. This 200 means the page is okay or respond is okay. And then here this is called MIME, or this is a type that is telling to the browser that if it is this content is image, text, audio, video, or type of content. So it says this is text HTML, so the browser knows how to treat it, and the page is also passed. So this is the content, this is the type. This handle not found, do not worry about it. This is needed in case if there is something goes wrong. This will be printed. And then inside the setup, we initialize the DHT.begin. This is for serial monitor with 115,200 baud per second. And then Wi-Fi station is defined, the mode, and then we pass the SSID and password, so the Wi-Fi begins, and then this just prints a new line, and then waiting for connection. So while Wi-Fi status is not equal to Wi-Fi connected, then if it is not connected, every 500 milliseconds it will print a dot, which I was going to show you next. So because this is print, not print ln, you see dot and then another dot, it will be printed every 500 milliseconds until the connection happens. When the connection happens, this will be automatically false, and while will exit. And then this prints again new line, print ln, and print this text, prints the SSID name and IP address. This is a text, and this will print the IP address. And here multicast DNS begin. Here you can type whatever value you want. As I put the Robojax DHT, and if this returns true or initialized, we print this text on the screen. And then this is where it goes to the root of the server and runs this content, which is the page. And this is also needed in case if you have different arguments or parameters. This will also work. And if server not found, this is a handling internally from the function. It will tell that server not found, and server.begin will begin the server, and then it will start this text for us. Inside the loop, server handle client will start the server, and this will start the multicast updated. This will DHT.read temperature, will read the temperature in Celsius and store it in C of type float. This C will be our temperature, or if you want humidity will be in H. And then these two are the same, except inside we have true. If this is true, the value will be Fahrenheit and will be stored in F. And then in a serial monitor, we just print C, and then we get the T value, temperature, and we assign the latest value to the T value, which will be printed on the page. And we have a 300 milliseconds. The loop will continuously take care of these tasks. I'm uploading the code now. So this is done. Let's open the serial monitor. You see the dot that I mentioned. Now it is reading, and let me stop this so I can explain it. It shows the IP address 192.168.1 and then 100, and multicast DNS also started. So we can access our temperature sensor reader on this IP address, or we can type our own value here, Robojax DHT. You don't worry about the IP anyways. So let's go. This is the 21st birthday of Google. Now let's type the IP here, 192.168.1.100. Now pay attention, this blue refresh shows the time that we set. And you see the none that you saw here, that was due to the time that when the temperature is not responding, the page refreshed and it did not get the value because there was 300 millisecond delay. Now let me apply some heat here. And as you can see, the temperature increased and it's still increasing at 40. Now it will slowly cool down. So it's still 41. It got 40. Now if I disconnect it, pay attention. You see that none, and if I connect it again, it will go back online. 39. Now I have this one set up exactly the same. I'm going to connect the wires to this. So I'm using the same color, so no worries. Now, as you can see, the temperature has decreased to 25 degrees. Here, if you connect DHT22, it will also work fine, except you have to uncomment this portion for DHT22 and comment this DHT11. And let's now access it by typing http://robojax DHT, and here you can see it that it shows with Robojax DHT as well. Now let's access it via your mobile phone. First you have to be connected to your Wi-Fi. I'm connected now to Robojax network. Let's open the browser and then type 192. I've already typed it, and here it shows the temperature. And let me heat up. So this will refresh in 3 seconds. And you see that it is already 36, and maybe it will increase to 40 or something. Apply some heat. You will see the value will change. Thank you for watching. This was how to use the ESP8266 with DHT11 or DHT22 to read the temperature over your Wi-Fi within the same network. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it at the comment section below. I try to answer and reply. If you want to get updates of my upcoming videos, you may subscribe now.